In this episode, we are architecting the beginnings of our interaction system. We will bounce between our interaction controller and interaction component scripts to implement picking up objects as well as throwing them. We will also be discussing the way the interaction system is set up and why it is set up in the way it is. And these two scripts are what we will be building the switch, wheel, door, and other functionality off of. All right, welcome back. If you have not seen the first two episodes where we built our character controller, you don't actually have to go and watch them. I might be the first person in all of existence to say that, but you really don't. As long as you have a player that can move about the scene with a camera, that's really all you need. From there on, we're going to build everything ourselves. So let's get started. So before we dive into any programming, what we're actually going to have to do is kind of talk about what we're going to be building here. And so right now, we currently have a player with a player script that handles the player movement, that handles the player jumping, the head bobbing, etc. Now, I want to separate the player's ability to interact with the environment into a node that I'm going to call the interaction controller. Now, the interaction controller does just as it sounds. It handles any interaction that the player may have with the world environment. So if the player wants to pick up an object, if they want to throw the object, if they want to pull a switch, if they want to open the door, turn a wheel, if they want to pick up an item and put it into their inventory, the interaction controller is going to handle all of those. Now we're also going to be building a reusable scene, which is just a node, but it's going to have a script on it that I'm going to refer to as the interaction component. And on the interaction component, we are going to define all of the interactable objects. So what happens when you pick up a random crate or a bottle off the floor? What happens when you go to open a door? What happens when you flip a switch? What happens when you turn a wheel, etc. Now, this interaction component is going to be able to be situated on every single object that you want to bring into your game, such that it can be made interactable by just interacting with the inspector in Godot. And what this system does as a whole, this interaction system, where the interaction controller interacts with the interaction component on various objects, it's a very robust system, meaning that it's very fleshed out and it's not prone to breaking at any point, but it's also flexible, meaning that if you want to bring in any asset pack, any asset you build in Blender, it's very simple to bring those in and have them working virtually out of the box with a few tinkering with the settings. So a little more in depth is that the interaction controller is going to essentially sit between the object and the player, and it will update things such as if the player wants a reticle to change. So if they're able to pick up an object, maybe you want a little hand to appear in front of the player's screen, or maybe you want to be able to focus on an object, and if you're looking at it, it will change color. I know games like Amnesia, what they will do is if there's an object that you can collect or interact with in a certain radius of the player, it will have a slight blue glow. And that helps in dark horror games to help the player find things they need. That's what our interaction controller is going to handle. So we're going to get started with the simplest of those, and that is just having the player pick up an object and move it around and drop it somewhere. So let's get started. So like I said, we want this to be reusable. So let's go ahead and create a new scene and just make it a regular old node. Not node 3D, not node TD, just a node. And we are going to call this the interaction controller. Go ahead and save it. I do not have a folder, so let's create a folder for it. Oh, excuse me. Right click and add a folder, and we are going to call this interaction, and this is going to hold our interaction code in our interaction scene. So now let's go ahead and save this. And in our action folder, we now have our interaction controller. And by saving it as a scene, we can now drag and drop this onto the player. So in the interaction controller, go ahead and hit the plus script sign and create the script for it. So let's figure out how to build some interaction. So we're going to kind of flesh out our interaction controller, but we can't do it all the way without having interactable components. So we're going to have to bounce between these two a little bit. So I'm going to go ahead and click on my player so we can see how our player is set up. So the big thing that we need to do is make sure that our interaction controller is marked by a unique name. And what that allows us to do is we don't have to find the interaction controller in the scene tree. We can just go ahead and click, drag with holding control and bring it in. And we now have access to our interaction controller. But how do we actually determine if we're about to interact with anything? So if we go back to our 3D view, you can see our player is looking in a certain direction, but we actually need to add a few nodes to get that up and running. So what do we need to add? Well, the first thing we need to add on the camera is we need to add a raycast 3D. So this raycast is pointing directly into the ground, which we don't want. We actually want it facing the way of the camera, which appears to be -2 meters in the Z direction. Now it is worth it to mention that the size of this raycast determines how far away your user, your player, has to be before they can interact with an object. So in a game like Minecraft where you can interact with blocks, I think it's 5 to 6 meters away, you'd want this to be closer to -6. I, however, find that in a puzzle or a horror game, you're going to want it to be a little bit closer. So I find that 2 meters is pretty good. We can adjust that if we need it. So let's go ahead and rename this raycast 3D to interaction raycast. And then the other thing that we're going to need, and make sure this is a child of the camera 3D, the other thing that we're going to need is a marker 3D. And this marker 3D I'm going to rename hand. And we want to put this transform at the very tip of your raycast. So my raycast is 2 meters, so I'm putting it at -2 meters in the Z. And this is going to represent where the player's hand will be. So unlike some games, like Amnesia or Five Nights at Freddy's, The Secret of the Mimic, we're not actually going to build this with having hands because that's a little more complicated and I don't want to get into the animation of it. However, this hand is going to represent where the player would be quote unquote gripping an object. So if you can picture a box down here where my cursor is twirling, the player's hand would be up here where the marker is. And when you click on it, you're going to want the box to move to where the player's hand is. And that'll make more sense as we get into this. So go ahead and save your player. We're going to go back into the interaction controller. And we're going to want access to the interaction raycast. And we're going to want access to the hand. But the only thing we really need to grab right now is the raycast. So I'm also going to mark this as a unique name and drag that in. Some other things we're going to need access to, I believe we're going to need access to the player's camera. I don't think we're going to get to that in this tutorial. In fact, let's also make sure that is a unique name. So now we have the camera 3D, and I'm going to rename this to player camera because we may have a different camera in the future. And that's everything we need from our scene tree. So let's go ahead and talk about some of the variables we are going to need. So the first variable that we are going to need is our current object. So let's create a variable, current object, and this is just an object type. So the current object is just a reference to the current object we're actually already interacting with. So we have grabbed it, we've picked it up, or it's a door and we're in the process of opening it. And that's why it's an object. We don't know if it's a rigid body 3D or some other kind of physics body. But we are going to need to keep track of that. The next node we need is what I'm going to call the var last potential object. And once again, this is an object. Now, the last potential object is just a reference to the last thing we possibly could have been interacting with. I don't know if that's going to matter for this tutorial, but I think it will matter once we start getting into things like collectibles. So we're going to go ahead and add it in now. And the final variable we are going to need is a reference to the interaction component, which is going to be a node. Now, the interaction component is going to be the node on the object. So let's say it's a chair that allows us to pick it up and move it around, or it's going to be on a door that's going to allow us to open it. So this will be gotten dynamically as we go through the process. And for the sake of this tutorial, I think the only method we are going to need is our process. And for now, we're just going to have it return. So in theory, we could go ahead and start writing logic for this, but I think it'll make more sense if we end up building our interaction component first. So let's go ahead and do that. So let's go ahead and create a new scene, a new node. This is also just a node. And this is our interaction component. This interaction component is going to get a script, and we're going to go ahead and put this in the interaction folder as well. So let's go ahead and create it. Let's go ahead and save this scene as well. So now we have two scenes that we can drag and drop on the player and on whatever component we want to interact with. So similar to the player state we made in the controller, we're also going to need to know what kind of object we're interacting with. It could be a door, it could be a switch, it could be a wheel, it could be a pressure plate, it could be just a bottle you want to throw. So we're going to define that as well in an enum, and we're going to call that our interaction type. And for the sake of this tutorial, we only have the default. Default is the term I'm going to use for any object that you just want to pick up. So obviously you don't want to pick up a wall, that'll be static, but you also don't want to pick up a door. So default is what we'll use for that. Now, the next thing we're going to need, and this is actually going to be an export variable. Export just means that we can set that in the inspector, and that's going to be necessary for these specific objects. So we're going to get a node 3D that I'm going to call the object reference. And the reason I need the object reference is that way we can define what rigid body is actually being moved when we click on it. And this will help if we bring in an asset pack and it comes in all kind of jumbled. It's very easy to just one click set it up. Like I said, this will all make more sense as we get into it. I think it's also worth noting that this is defined on individual objects in the game. And the reason I want to write that out is for our next variable. Once again, this is going to be an export variable. And this is going to be the interaction type, which is going to represent the enum we just built. So this interaction type is going to be default for this specific object. When we build a door, we are eventually going to have a door interaction. And that just helps us know what logic we actually want to be doing. Now we're also going to need some internal variables to keep track of what we're up to. And I think for the sake of this tutorial, we only need to know two things. We only need to know one, if we can interact with this object, because based on gameplay elements, you may not want the player to interact with something, but by default, we're going to set that to true. The next thing we need to know is if the player is currently interacting with this object. And that's false by default because this crate or box or bottle is somewhere in the world and the player probably hasn't found it yet when the game starts. And I think those are the only two variables that we're going to need for now. So let's go ahead and talk about the functions we'll need. The first thing we're going to need is we are going to need to implement our ready function because we are going to need to know a few things about this object when the game first starts. We are also going to build some functions that I'm going to refer to as our pre-interact, our interact, and our post interact. Now, what are these? So our pre-interact is going to run once when the player first clicks on an object to interact with. And this is going to set things up about the object or grab information about the player that we need to perform some logic. So then obviously we need an interact, which is going to run every frame and perform some logic on this object. And that makes sense. We're interacting with something, we need to have an interact function. And similar to the pre-interact, we also need a post-interact, which I'm noticing a typo, runs once when the player last interacts with an object. So if I'm holding an object in my hand and I decide to drop it, the post interact will run the frame after I let go of the left mouse button. The other function we're going to need is our input function. So go ahead and grab our input event because some of the things we're going to be doing are going to be dependent upon the mouse. This will not be, we're just going to go ahead and return, but let's go ahead and set that up just anyway. And we will be adding to this, but for the sake of this tutorial, we're going to leave it at that. So let's go ahead and start thinking about some of the logic we're going to need. So we have a pre-interact, we have an interact, and a post-interact. Now, the simplest thing we need to talk about is the pre-interact. So when we first start interacting with an object, what do we do? Well, we want to say that this object is interacting with the player. So we're going to want to set that to true. Similarly, when we post-interact, when we are dropping this object, we then want to set that value to false. So that way, any checks we do will tell us, are we interacting with this object or not? And it should always be accurate. Now, the next thing we need to check is when we interact with something, we need to check if not can interact in return. So this is a little clunky, but it's essentially saying if we can not interact with this object, don't perform any interaction. Like I said, in this tutorial, this probably won't come into play, but that is a good check to have for this system. So let's go ahead and think about how we are going to do this. Let's go ahead and create a new scene. We're going to make this a 3D scene, and we're going to change the type. And we're going to change the type to a rigid body 3D. Let me go ahead and go into our 3D view. Now, a rigid body needs two things. It needs a mesh instance, and it needs a collision shape. The collision shape is going to be a box, and you might be able to guess that the mesh is also going to be a box. So we want to add a material on this so that way it's not a white box. So how we're going to do that is go to our prototype textures, go to, let's say green, and just drag a texture into, let's just drag it over the object. That should be nice and simple. And I'm going to rename this, and this is going to be cube underscore 1 kilogram. And the reason I'm adding underscore 1 kilogram is because the mass here is 1 kilogram. Now we're going to build our system based on the weight of the objects. So light objects are going to be able to be thrown farther, they're going to be picked up faster, whereas big heavy boxes are going to take their time to come to the player. So we now have a 1 kilogram cube. We are going to actually create a new folder. We're just going to call this objects, and we're going to save this under the objects folder as a cube. So there it is. And just to show you, we have our interaction folder, and we have our interaction component. Now, eventually, we're going to drag and drop this on here and upon all our cubes. But let's not get ahead of ourselves. Let's get back to scripting and set up how this object is actually going to interact with the physics in the world and interact with the player. So a quick jump back to the player. The first thing we need to do is get where the player's hand is. So as you can see, the player is going to have an interaction controller, but the object isn't actually going to know how to interact with the player. So what do we need to do? We actually need to send the location of the hand to the interaction component and tell it where it needs to go when the player begins to pick it up. Now, the simplest way to do this is in the interaction component. When we perform our pre-interact, the first thing we need to do is check what kind of object we're interacting with. We're going to check our interaction type, and if it is a default type, we're going to do something. Now, the reason, we're going to match the interaction type, and if the interaction type is default, we're going to do something. All right, so this is much better. Now, the reason we're doing this is because things like switches, things like doors, things like wheels don't actually need to know where the player's hand is. So you only want to make this call when you absolutely need to. So if we're dealing with an object that needs to know where the player's hand is, we're going to say that the player hand, which is once again a variable that we did not set it up. So we are going to need a reference to the player hand. Var player hand. And the player hand is a marker 3D. So in this situation, we're going to say that the player hand, now we don't know, if you picture this cube, we don't know where the player hand is, so we're going to have to go and find it. So we're going to get the tree, which is all the nodes in the scene. We're going to start at the root, and then we are actually going to find child. Now, find child is going to find a node, and the node that we need to find is based on the name. So we named it hand, which is what it is in the player, and we also want it to search recursively, and it does not need to be owned. So what this will do is the first time we click on a box to pick it up, it'll say, hey, here is where the player's hand is. You might think about going there. So let's go ahead and build the actual interaction for picking the object up. So to do that, I'm just going to go ahead and copy this logic,
And after the if not can interact in the interact function, let's go ahead and close some of these up. I'm going to paste this and remove the player hand. So if we are now interacting with the object, we're going to want to do something every frame. And I'm going to go ahead and define that in a different function called default interact. And down here at the bottom of my script, I'm going to create a function called default interact, which is a returning void. So let's define how we're going to interact with the object. So just for the sake of showing how this is going to work, I've added in a temporary mesh instance here. So you can see here's the hand and here's the mesh instance. So we need to know a couple things. We need to know where the mesh instance is in the world, and we need to know where the player's hand is in the world. And then we're going to use those two to calculate the distance between where the box is and where the box should be. So let's go ahead and get rid of that and go back into our script. I'm going to go ahead and remove the return, add in some enters so that way this is closer to the center of our screen. And let's go ahead and get those variables. So the first thing we care about is the object's current position. This is a vector 3, which represents where it is in the world. And this is our object reference, and that is its global transform origin. Now remember, the object reference we're going to set up to reference where, to make a reference to the object itself. And this will make more sense once we set up the interaction component. But this position represents where the box is in the world. Now the next thing we need to know is where the player hand is. So we have the player hand position. Once again, this is a vector 3. This exists in a 3D world space. And this is the exact same. It's just the player hand at the global transform origin. And now we need to calculate the distance between. So we just say var object distance. Once again, this is a vector 3. We are dealing in 3D world space, which is just the player's hand position minus the object's current position. So now we actually need to make sure that this object is a rigid body 3D. And the reason we need to do that is because we are going to throw this object, which means we need to set its linear velocity, and we want it to bounce and or crash and or bang and have some kind of physics interaction with the world. So we're going to say that it is a rigid body 3D. And we're just going to call it rigid body 3D. And we're going to set this equal to the object reference, and we're going to say as rigid body 3D. And what this line means is that if the object reference is a rigid body 3D, this will be populated with a value. If it's not a rigid body 3D, because remember, we just defined it as being a node 3D because we may reuse this for different interactions later down the line. If it's not, this will be null. So we want to check if rigid body 3D is null, because if it is, we don't want to try to perform logic that's going to break our game. However, here's actually the logic for picking up our box. So we have our rigid body 3D, and like I said, we are going to set its linear velocity. And how do we define its linear velocity? Well, the first thing we need is the object distance, because remember, what we're doing is we are pulling the box toward us, and this is going to run every frame that we're interacting with it. So we need to keep track of where the object is relative to the player. And that's going to be multiplied by a constant value, which is a certain speed. I just find 5 to work. You could export this and play with it as you needed. But the big point of this is that it's actually going to be a ratio relative to the rigid body 3D, if I can copy and paste, a reference, it's going to be a ratio to its mass. And what this line is going to say is that if it's a very light object, if you think of like a bottle or a small brick, it's going to come right at the player's face very quickly, and it's going to follow the player's camera very tightly. But if it's a big, heavy box, it's going to move slow, and it's going to take a second to move around. And it's going to give the objects we interact with a little bit of weight. So now that we have this logic written, let's go back to our cube, let's look at it in 3D space, and we're going to take the interaction component and we're just going to drag and drop it onto this cube. So you can see over here in the inspector, we have some options. We need a reference to the object, which in this case is the rigid body 3D. So set that to the cube. And then we have to define its interaction type. So we only have the default because that's what it is. And there you go. Now we have an object that we can interact with. So let's go back to the interaction controller and actually set up how the player is going to tell the box what to do. All right, so back in the interaction controller, this logic is going to be a little complex, but I promise I'm going to try to explain it as best I can and as slow as I can as we go. So remember, the process function is going to run every single frame, and while this interaction controller sits on the player, we're going to be constantly checking things. So what do we actually need to know if we're interacting? Well, we need to know one thing. We need to know if we're currently interacting with something. So if, let's think about this chronologically. If on this last frame, the frame that just happened, if we were interacting with something, we want to keep interacting with something. So let me go ahead and write that down. If on the previous frame, we were interacting with an object, let's keep interacting with it. And this else statement would mean that on the previous frame, we weren't interacting with something. Let's see if we can. So let's think about this chronologically. We actually want to start with this else block. I think that'll make more sense. So we just started the game and we're not interacting with any of the objects in the 3D environment. So what do we need to know? Well, we need to know if there's a potential object that we're looking at. So our potential object, which once again is just an object. We don't really know what we're looking at quite yet. And then this is just equal to our interaction raycast dot get collider. And so what this is, the interaction raycast, if I go back to my player, this is just going to return if we're staring at anything, if anything is hitting this, it's going to check and say, hey, you could potentially be interacting with this object. But of course, this will also return if we're hitting a wall or something that we don't want to interact with. So we need a little bit more logic after that. So how are we going to check this? Well, the first thing we're going to do is we are going to see if we have a potential object. So if we're not colliding with anything at all, in that case, this will be null. So this is our first check. We also want to check if the potential object is a node. Now this is more of a safety check to make sure that it is something that Godot can deal with. Now this is not terribly important, but I have run into issues before with this. But the big thing here is we need to make sure that we have something we're looking at. So we have found something, but we want to know if it's interactable. Now, in this case, we're going to know if something is interactable if it has an interaction component attached to it, such as the cube we just made. So the next thing we need to do is we need to try to get its interaction component. So we're just going to go ahead and say the interaction component, which is the variable we defined up here, is going to be equal to our potential object dot get node or null. And this is going to return either the node we're looking for or null. And what is the node we're looking for? Well, we're looking for the interaction component. So remember, if we are trying to interact with this cube, what we would find, let me add a return statement so there's no error. If we were trying to interact with the cube here would be the potential object, and we would try to get a node called interaction component, which in this case we would find. In any other case with something we can't interact with, we would not find it. So now that we potentially have an interaction object, let's go ahead and check if it's null. So if we have an interaction component. Now, the big thing here is that we also need to verify if this interaction can be, if this is allowed to happen. And the way we define that was if the interaction component can interact. Well, mostly we want to check if it can interact, if that's false. So if we can't interact, then we want to return. So if for some reason we decided via gameplay or some other reason that we should not be picking up this cube, return now and don't do any kind of logic. So at this point, we have now found an object that exists, an object that can be interacted with, and an object we are allowed to interact with. So at this point, the last potential object is now the current object. This won't come into play now, but this will be important in the future. So now that we know that, we need to check if the user, the player, is trying to pick this object up or interact with it in some way. So we need to check if the action that pressed is primary, meaning left mouse button to pick the object up. And if we are trying to pick the object up, we're going to say that the current object we're interacting with is the potential object, because right now we're clicking on it. We're saying we want this to be the current object we're interacting with. And finally, we need to tell the object we're interacting with to do its pre-interact functionality. So for the sake of the cube, we're going to tell it, hey cube, do your pre-interact. And what is the cube going to do? It's going to go and find the player's hand. Where is my pre-interact? It's going to go find the player's hand. So that way, when we call the interact method, it's going to have that to perform that calculation. So that's great. That's our first frame. We just found something to interact with, and now we're trying to interact with it, but this only happened on one frame. What happens now that we found the object and we're trying to interact with it? Well, now that the current object has been set here, the next frame, this will be true. So now we need to build out the first if branch we skipped over a little before. So we need to check if we're still trying to interact with the object, because we could have just, clicked on it once by accident. So we want to check if the input is action not just pressed, if the is action is pressed, meaning if we are still holding down left mouse button, we are going to want to do the interaction component dot interact. And one thing we should check is we want to make sure that we still have that interaction component. In this simple case, that's probably not a problem, but as we get more in depth with collectible items that will actually leave the scene tree, this could perform poorly. So now we're going to interact with that object. So now we've picked up a box and we're moving throughout our scene, and let's say the player wants to drop the box and no longer wants to interact with it. We need our final interaction. So that's going to happen here because we'll have a current object and the player will let go of the primary key. And once again, just for safety, we're going to ensure that we have the interaction component still stored. And what we're going to do is we're going to say interaction component dot post interact, which in this case will tell the object that it's no longer being interacted with. We are going to say that our current object equals null. So that way, when we let go, we can immediately start searching for another potential object to interact with. So let's go ahead and save that. All right, so I think this is all the logic we need to be able to pick up a box. So let's go to our sandbox, go into 3D mode, and we are going to drag and drop our cube right there. And let's go ahead and hit play. Let's look at our box. I'm going to hit left click, and as you can see, the box will follow wherever the player's hand is. I can move it, and I can let go. And it will now behave as a physics object should. So just to show how easy it is to use this system to import assets and make them viable, as well as the fact that the weight of the object will affect its behavior in the physics process, let's create another cube. So we're going to create a 3D scene. We are going to make it a rigid body 3D as well. And this is going to be a cube, and I'm going to make it 5 kilograms. That's going to need a mesh instance. It's also going to need a collision shape. Both of these are going to be the standard box. And let's go ahead and drag a texture on it. Prototype textures, red, because red means heavy, and drag it onto the box. Now the big thing here is this cube is no longer 1 kilogram, it is now 5 kilograms. Now to make this object interactable, the only thing we need to do is take the interaction component and drag it on the cube, take the object reference, and assign it to the rigid body. No extra logic had to be defined, and we can go ahead and save this in our objects. So if we go back to the sandbox in 3D space, click objects, drag the cube in. I'm also going to just move our player, perhaps turn them so that way they're facing the object Makes it nice and easy when you're debugging. So now if I go over to this cube, I can pick it up and you can see it's heavy. It's going to move nice and slow, just like I do. So now if I pick up our light box, I can put it on top, grab the lower box, pick up both. Oh, look at that. It got top heavy. And they'll spin around and they'll interact with each other and they'll move through the environment. So obviously there are some improvements you could make, but it's pretty simple to get two objects up and running and interactable. So now that we have the interaction controller and the interaction component fleshed out, all we need to do is add more interaction types to get this whole system up and running. So I'll see you in the next one when we start working on the next possible option, which I believe will be doors. And this is a little post-credits scene. One thing I've noticed is that this player hand is going to have to be found in the scene tree every time we interact with an object, which isn't great. This could be a pretty demanding call depending on what is in the scene tree. So let's improve this a little bit. So the interaction controller, which sits on the player, can actually know where the hand is. So let's go ahead and access this as a unique name and bring it in. And then the interaction component, when we do our pre-interact, where is that down here? Let's just send it the hand. So now in the interaction component, the pre-interact, that's just going to be expecting a hand, which is a marker 3D. And we already have the player hand marked out here. So we'll just say the player hand is equal to the hand. So let's try this and see if it works. All right, so we're launched. We try to pick up this box and it appears to be working just as we expect it to. So I don't know if that would be a performance hit. I could imagine a game where you have many, many things in your environment and the scene tree is very, very large. Perhaps it would, but now it doesn't. So a short little improvement, and I hope you stuck around to find it.
And it wouldn't be a tutorial if you did not forget to do something again and you have to add it in at the end. Now we are able to interact with our objects, pick them up and drop them, but we aren't actually able to throw them. So let's go ahead and implement that now. So here in our interaction controller, you can see we can hold down our left mouse button, our primary, and continually interact with the object. However, we just want to be able to throw the object as well. And the way we're going to do that is we have bound to our right mouse button our secondary. So what we're going to do is we're going to check here. If input is action just pressed, and this one is secondary, this one is secondary, then we're going to want to throw the object. Now we also need to make this an elif. Now the reason we're doing this is if the secondary object is not a counterpoint to the primary, the player will never let go of it. So we need to check first if we're trying to throw it, and then if we're not trying to throw the object, then we can go ahead and keep holding it. So once again, we're just going to add in to check to make sure that we have our interaction component. And if we do, we are going to call it, and we are going to call a function we're about to write, which I'm going to call aux interact, standing for auxiliary interact. Now this is reusable because if you have other objects in your game that you want to use the right mouse button to do something, we don't have to call this just throw, right? We can reuse this for a couple different things. The big thing we need to take into account with this is that the aux interact should only do one action on the object. For our case, we're only throwing it. So in that situation, we are going to want to call our post interact because as we throw the object, we don't want to be holding on to it anymore, and we want to make sure that all of its values are reset. In fact, we're going to add that inside the aux interact functionality just to be certain that we can reuse this method for other objects. And the only thing we need to do here is also set our current object, to null. So let's go ahead and write the logic for the aux interact. So here in the interaction component, just after our interact function, we are now going to perform our auxiliary interaction. And this is going to have the same exact logic as the interact, except instead of calling default interact, we're going to call default throw.
So if you wanted different logic for different interaction types, this is where you would add them. And then just here under default interact, we're going to call default throw. You could just call it throw. I don't think I'm going to add different kinds of throwing methods to the controller, but I think it matches the same principle. And to throw something, it's actually fairly simple. The only thing we need to do is kind of copy and paste the same code from the default interact and change the way the linear velocity is going to be calculated. So I'm going to go ahead and grab this, copy it down here. And so this is the logic here to actually just hold the object in front of us frame after frame. However, we're going to need to do some calculations. Now, we need to know two things to be able to throw an object in a general direction. The first thing we need to know is the direction. So how do we calculate what direction we're going to throw the object? Well, we know where the player's hand is, and we know where it is in world space, so we can get its global transform basis. Oops, if I can learn to spell. Now, which axes do we need from the player hand? Well, if we go into our player and we look at our interaction raycast, you can see that it's on the Z axis, right? So what we actually want is we want to use our Z axis to calculate which way we're facing, and we want to throw the object the opposite way, right? So that's what this negative here is. So we're going to get the way the player's hand is facing on the Z axis, and we're going to normalize this so that way it's just a value between 0 and 1. And we're going to throw in the opposite direction in which the player's hand is facing. And this should be normalized, not normalize. Now, the next thing we need is how hard we are going to throw the object. So we need to know our throw strength, and this is just a float. I think I'm just going to hard code a value like 20. But the big thing to make note is similar to the way we had the rigid body's mass make a calculation during the set linear velocity, we also want that same ratio to apply here. And the reason why we want that is because heavier objects should not be able to be thrown as far as light objects. So now, no matter what object we set this up for, big objects are going to be heavy and can only be thrown so far. So now we just need to perform the actual calculation where we have our rigid body 3D. We want to set its linear velocity, and we're just going to set that to our throw direction times our throw strength. So this should make sense because our throw direction is going to be a vector 3, so it's going to represent somewhere in world space. And that's normalized, so that's going to be a value between 0 and 1, and that just tells us in a general direction where the player's looking. And then we just want to launch that sucker as hard as we can, and we'll see what happens. Now, this is not going to work right out of the box, but I do want to demonstrate what this is going to look like. So let's go ahead and hit run. So if we come over here, I can still pick up my boxes. One is heavy, one is light. But if I right-click the mouse button, you can see that it's kind of jerking back to the player. And the reason why is the very next frame after we throw it, it's still within our grasp, meaning that we can still interact with the object. So let's go ahead and hit escape. And the way we are going to fix this problem is here at the very end of our default throw method, we are going to want to set our can interact to false. Now, this will prevent us from being able to interact with the object. But this will also come with a problem. If we can right mouse button, we can throw it. But as you can see now, I can never pick this box back up. So the solution to that is I am just going to set a timer that prevents you from interacting with the box to give it enough time to get out of your interaction raycast. And the way we're going to do that is to create a timer, we're going to say await, get tree, create timer. I think 2 seconds is a good number. And then we are waiting for it to time out. So what will happen is, as this code runs, it'll come down here and it'll wait 2 seconds. And after that 2 seconds is up, we just set our can interact back to true. So let's go ahead and run this. Let's grab our light box, chuck it against the wall, and we can now pick it up again. And as you can see, we can left mouse button and move it all around while clicking. But as soon as we throw it, We have to wait 2 seconds to be able to pick it up, which seems like a good amount. Now let's go ahead and make sure that our heavy box is also harder to throw. Yeah, so let's go ahead and pull these back. So let's say right about here, and I throw this at the wall, flies, goes bouncing. If I grab the red box, pull it back to roughly where we're at, and throw, it doesn't even get to the wall. So there you go. That's how you implement throwing objects, and I hope that works out.